Hello friends and my hello friends and my dear students. I welcome you all to my channel. So this is part 3 video on the chapter of limits, where I will discuss about the obviously intuitive arithmetic arithmetic of tending values, especially when the variable x tends to 0 or plus minus infinity. Then what happens when we do multiplication or division, or take the power of two tending values. uh, this is a very critical thing to understand, because it will be rigorously applied to understand the form of any limiting function, and that will lead to the correct solution. So this video is part of the playlist Problematic Mathematics for Class 11, where I will be primarily discussing the key concepts and formulas related to, focused primarily to solve problems that comes in competitive examinations like JEE Mains, JEE Advanced, or WBJEE. And if you find this video beneficial, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not do not forget to press the bell icon so that you will be notified by my future videos. Okay, so I have written down all the arithmetic operations between two tending values, but we need to be cautious when those tending values are the exact values. What happens when the values are tending and when the values are exact? Now, as you can see, most of the values are tending. You can see that the notation I have used is that this means a value which is tending to 0, and obviously now infinity, the value infinity and tending to infinity, they are the same thing. Infinity or tending to infinity means the same thing, or tending to minus infinity and minus infinity, they means the same thing. Minus infinity means the value is tending to minus infinity, or infinity means the value is tending to positive infinity. And wherever I have written 0, it means exact 0, and that is, if I have not mentioned the tending symbol, then it means the exact value. Okay, now let's see the major and critical operations. The first is tending to 0, plus minus tending to 0. What will be the result? Will it be a value tending? Will it be a tending to a value, or it will be an exact value? Obviously, this will be tending to 0. This will be tending to 0. That is, tending to 0 plus tending to 0 tends to 0, or tending to 0 minus tending to 0 tends to 0. Okay, that was easy. Similarly, second one, tending to 0 multiplied by tending to 0 also gives a value which tends to 0. Okay. Now, what happens when you multiply 0, exact 0, with a value tending to 0? This will not be tending to 0, but it will be exactly 0. When you multiply a value which is tending to 0 with exact 0, then the value is always exact 0. Okay. Third one, tending to 0 divided by tending to 0. This is an indeterminate form. We cannot deterministically say to what value it will tend. So we say this is indeterminate form, which we any limiting problem, if the limiting function is of this form, that is, when we put the value of x, the tending value of x, and if we investigate the form, if it is of the form tending to 0 by tending to 0 divided by tending to 0, this is an indeterminate form, which we solve by some specific methods that I will discuss in future video. So this is indeterminate. We say indeterminate form. This is one of the indeterminate form. Now, what will happen? What is 0, exact 0 divided by a value tending to 0? This is always exact. 0. Similarly, what will be 0 exact 0 divided by plus minus infinity? This will be exact 0. Remember, this will not be tending to 0, but it will be exactly 0. So if the numerator is exactly 0, and of course and the denominator is tending to 0, it is not 0. If it was 0, then it would have been undefined, not defined. So anything division by exact 0 is not defined. So in that case it would be undefined, but tending to 0 means it is not 0. It is a little greater than 0, or it is little less than 0. So 0 divided by tending to 0 is always 0, and 0 divided by plus minus infinity is also equals to 0. Fourth one, we have tending to 0 raised to the power tending to 0. Tending to 0 raised to the power tending to 0. This is an indeterminate form, because we don't know what immediately we cannot say deterministically that to what value this exponential form will tend to. We use some special method for solving limiting problems which are of this form. So this is also an indeterminate form. Indeterminate. There are 7 or 8 indeterminate form. We will see. This is indeterminate form, tending to 0 raised to the power tending to 0. Okay. Next is tending to 0 raised to the power minus infinity. Now tending to minus infinity is equal to minus infinity. Okay. So this is I can say no. This can be this is equivalent to since it is the power is minus infinity, I can say this is 1 by tending to 0 whole raised to the power infinity. Now when I write infinity, it means tending to infinity. So what will be 1 by tending to 0 raised to the power infinity. Okay. Now for this we need to know first what is tending to 0 raised to the power infinity, where we have this. So tending to 0 raised to the power infinity, it is always tending to 0. This is tending to 0. Tending to 0 raised to the power infinity is always 0. Remember that this is always 0. Remember that this is tending to 0. If it was 0 raised to the power infinity, it would have been exactly 0. But we are having tending to infinity, raised to the power infinity is tending to 0. So now what will be 1 by tending to 0 raised to the power infinity. In the denominator we will have tending to 0. So this will be, so 1 by tending to 0, 1 by tending to 0 means tending to infinity. Okay. Now what is 0, exactly 0, exact 0 raised to the power a value which is tending to 0 positive. 0 positive. This will be exactly 0. If you have an exponential form where the base is exactly 0 and the power x, it is anything other than 0, then this will be always equal to 0, where we must have x not equals to 0. So exact 0 raised to the power or value tending to 0 positive is exactly 0. Similarly, 0 raised to the power a value tending to 0 negative, 0 minus, this will also be exactly 0 because what is tending to 0 negative? I can equivalently write tending to 0 negative as negative of tending to 0. Negative of tending to 0. So 0 raised to the power tending to so this will be eventually 1 by 0 raised to the power tending to 0, and 0 raised to the power tending to 0, 0 raised to the power tending to 0 is 0, it is exactly 0, and so uh, uh, so this is a 0, exact 0 raised to the power value tending to 0 negative is actually not defined, because we are having 1 by exact 0 raised to the power a value tending to 0. Now 0 raised to the power 0 raised to the power anything a value tending to 0 is 0, so 1 by 0 is undefined, so this will be undefined. Now please let me know, I could be wrong in with some results. If that happens, then please feel free to let me know in the comment section. I will appreciate that. So this is undefined, that is exact 0 raised to the power a value which is tending to 0 negative is undefined. Okay, now what is exact 0 raised to the power infinity? So we know that 0 exact 0 raised to the power anything, and that power is, and if that power is not equal, is a non-zero number, then it will always be equal to 0. Okay. What is tending to 0 raised to the power 0? Tending to 0, a value tending to 0 raised to the power 0 is always equals to 1, because if you have x is a variable, real number, to the power exact 0 will always be 1, provided x is not equals to 0. So tending to value 0 is of course not equals to 0, so it is either little greater than 0 or less than 0. So tending to 0 whole raised to the power exact 0 is 1. Okay, let's see the fifth one. Infinity plus minus tending to 0 is, of course, we have infinity. This is easy. Infinity plus infinity is, of course, will tend to infinity. I mean, tend to infinity, or if I say equal to infinity, they mean the same thing. Now minus infinity plus minus infinity will of course tend to, or will be equal to, minus infinity. Now infinity minus infinity, this is an indeterminate form. This is another indeterminate form. I will specifically address the indeterminate form in separate video, and how to solve problems, limit problems which are in the indeterminate form. So infinity minus infinity is indeterminate form. Okay, ninth one. Infinity raised to the power 0. Infinity raised to the power 0 is again an indeterminate form. Indeterminate form, we cannot immediately say what value it will tend to unless and until we solve it using some specific method. So infinity raised to the power a value tending to 0 is indeterminate form. Also note that infinity raised to the power exact 0 is 1, because as I said, x raised to the power 0, if x is anything other than 0, then it will always be 1. So infinity raised to the power exact 0 is 1. What is also minus infinity raised to the power 0 is also equal to 1. Exactly equal to 1. Okay. 10th one, infinity raised to the power infinity will always be equal to infinity or tending to infinity. Infinity raised to the power minus infinity. Infinity raised to the power minus infinity, I can equivalently write it as infinity raised to the power this will be equivalently 1 by infinity to the power infinity, which will tend to 1 by infinity. So this will tend to 0. So infinity raised to the power minus infinity is 0. It will tend to 0. Tend to 0. Okay. Now let's say k is a fixed real constant greater than 0. K is a constant real number greater than 0. Then what will be infinity to the power k? It will be definitely it will be equal to infinity or will tend to infinity. What will be infinity to the power minus k? So this is equivalently we can say 1 by infinity to the power k, and this will tend to 1 by alpha infinity to the power k is tending to infinity. So 1 by infinity will tend to 0. So infinity raised to the power minus k, where k is some positive real number constant, real constant, it will tend to 0. Okay. 12th one is also very special. It is infinity by infinity. So it is infinity by infinity. So in the numerator it could be plus minus infinity, or and the denominator could also be plus minus infinity. In all the cases, in all the 4 cases, this is an indeterminate form. Again, this is an indeterminate form. Solving limiting problems where we see that putting the tending value of the x, it is of the form, it is coming to any one of the indeterminate forms. Solving those problems is very important and very critical. I will solve those kind of problems rigorously in future videos. So this is again an indeterminate form. 13, tending to 0 divided by infinity, plus minus infinity. This will always tend to 0. So tending to 0 divided by plus minus infinity is always tending to 0. Whereas 0 by plus minus infinity is exactly 0. Okay. Infinity by value tending to 0 positive. This will be obviously tending to or will be equal to infinity. Whereas infinity by basically actually how is it working is that the if so infinity actually 1 by so this is actually if I am omitting the tending value with infinity because tending to infinity is same as infinity. So this is actually infinity multiplied by 1 by tending to 0 positive. Now 1 by tending to 0 positive, 1 by tending to 0 positive is always positive infinity. So this is equal to infinity multiplied by infinity, which is equal to infinity. Whereas infinity divided by tending to 0 negative, this is infinity multiplied by 1 by tending to 0 negative. This is equal to infinity multiplied by 1 by tending to 0 negative is always negative infinity. So infinity multiplied by negative infinity is nothing but negative infinity. So infinity by tending to 0 negative is negative infinity. Okay. So again negative infinity divided by tending to 0 positive, this will be equal to infinity multiplied negative infinity negative infinity divided by tending to 0 positive. This is negative infinity multiplied by 1 by tending to 0 positive, which is negative infinity multiplied by 1 by tending to 0 positive is always infinity. So infinity. So minus infinity multiplied by minus infinity is minus infinity. Whereas negative infinity divided by tending to 0 positive 0 negative, this will be equal to minus infinity multiplied by 1 by tending to 0 negative. This is equal to minus infinity multiplied by 1 by tending to 0 negative is always negative infinity. So negative infinity multiplied by negative infinity, this is equal to infinity. So minus infinity divided by tending to 0 negative is always equal to infinity. Okay. 14th is tending to 1 raised to the power infinity. This is also an indeterminate form. Indeterminate form. So an exponential form where the base is a value tending to 1 and the power is infinity. I mean infinity or tending to infinity, it means the same thing. It is an indeterminate form. We cannot immediately say what value it will tend to. Whereas exactly 1 raised to the power infinity is equal to 1. Also exact 1 raised to the power minus infinity is nothing but 1 by 1 raised to the power infinity. This is also equal to 1. Is equal to 1. Let's see. Okay, so there are nothing. Yeah. So I think I have covered most of the critical arithmetic operations involving the special tending values that you will encounter in determining the form of the limiting function. When you are given a limiting problem, you first substituting the tending value of the x, you first determine what is the form. That is the in most cases it will fall in one of the indeterminate form. So what are the indeterminate form we have discovered? The last one was now the last one, usually we say the indeterminate forms are 1 to the power infinity. Over here we mean it is not exactly 1 but a value tending to 1. So this is one indeterminate form. The other one was infinity by infinity. Now generally we do not say plus minus infinity by plus minus infinity, because infinity by infinity because minus infinity by infinity is nothing but negative of infinity by infinity. The negative sign is not a problem. The problem is infinity by infinity. So that is the indeterminate form. So in general, infinity by infinity is another indeterminate form. And then infinity to the power 0. Infinity to the power 0. Obviously over here 0 is not exact 0, but it is the value tending to 0, and it is the base is infinity. When we say infinity, obviously it means tending to infinity. Let us see what are the other indeterminate forms. Infinity minus infinity is another indeterminate form. Infinity minus infinity. Okay, let's see. So 0 to the power 0 is another indeterminate form. 0 to the power 0. Over here, remember that both the base 0 and the power 0, they are tending to 0. They are not exact 0. And I think the last one is 0 by 0. 0 by 0. Okay. 0 by 0. 0 by 0. So 0 by 0 means tending to 0 divided by tending to 0. So these are the 7 indeterminate forms which are very, very important to address. You must be able to solve limiting problems which are in the form of these in which are of one of these indeterminate forms. I will solve a lot a lot of problems addressing each of these form in future videos. So I think this video will be beneficial for you to understand, to apply the very basic arithmetic of tending values. Now the tending values, especially tending to 0, tending to infinity, both the exponential form, subtraction, addition, and division, multiplication form, because these are the very foundational concept to establish, to understand the form of any limiting function based on the limiting value of the variable. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now as you can see that my videos are not really very sequentially, it is not very organized, so I am really sorry for that, but content in this playlist will always come in this fashion, this manner, but I will try to address the most critical concept or points which will help students to in solving the problems. So for the limit, I think the next video I will discuss about the I will discuss about the I think I will start solving. I think I will start solving. I will start discussing how to solve the exponential indeterminate forms, because those are very critical. Exponential indeterminate forms are the three ones: 1 to the power infinity, infinity to the power 0, and 0 to the power 0. These are the three exponential indeterminate forms. I will try to solve. I will try to discuss how to solve this kind of limiting problems that confines to this form one by one. So please stay tuned for these upcoming videos. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.